Okay, hi guys. This video is about how we can use our calculator to save a lot of time and effort with doing differential calculus. So we've got some questions here. I've got this function, it's a crazy function. It's trigonometric, it's not polynomial, it's a nightmare. Okay, I will actually give you the techniques that are required to differentiate a function like this, but you don't know to yet. So if you ever got anything like this at the moment, what you can do is use your graphic display calculator to do it. Okay, so I'm just going to show you how we can do more difficult functions with a graphic display calculator. So first things first, because this is trigonometric, I don't need you to understand this just yet. Just do it so that your calculator does the same for you. Go to the run matrix, okay, and then go shift menu for the setup and go down to angle. I'm pretty sure yours will say degrees, okay, DEG. What I want you to do is change it to radians, okay, so you're going to push F2 for radians. It's a different way of measuring angles, okay, which we use for trigonometry. We're going to learn that, but you don't know it yet. So just do that, make sure, otherwise it will all come out wrong. Okay, right. Now what we're going to do is we want to answer these questions. So find the local maximum, local minimum values of this function. So normally what I'd ask you to do here is differentiate it, find S prime t. But you don't know how to do that. You don't know how to differentiate a function like that yet, so you don't have to. You can find the minimum and maximum points by simply going to the graphing section of your calculator, okay, and put in the function. So you're going to go, you have to put in x, your calculator doesn't understand t, so you're going to go x squared cosine of x plus 2x sine of x, okay. Now we're going to go to draw it. Now mine's come out nice. Yours may have come out that you can't see the same as me. Well, all I've done is I've gone to F3 for the V window, change the x values you're looking at. Now you're told the domain of this function is t values of 0 to 5. So you want to make x values 0 to 5. Your y values, you just have to play around with them to get them where you want them to be. So I've gone from -20 to 5. But you know, you can do really whatever you want so that you can see the maximum and the minimum points within the domain. So I'm going to change that to -15 through to 10, just for argument's sake. Okay, so, and then draw it. And that's what it looks like. Okay, that's no good because it can't see the minimum. So I'm going to change it again. I need to see more in the negative, so I'm going to change that back to -20 and draw it again. Okay. So I don't really need to be very clever here. I can get the calculator to tell me the minimum and maximum values by going F5 for gsolve and find the maximum point. It's when x is 1.52, the maximum y value is 3.15. Okay, and we can get it to do the minimum. Okay, when y equals when x equals 3.99, the y minimum y is -16.5. So the x value that gives me the minimum is 3.99 and the minimum is -16.51. So your calculator does that for you. Okay. Right, now what you need to do is now we're going to go shift setup, and you can see here we're going to push the derivative on. Okay. And draw. Okay, now what we can do now is we can trace a point. So what I want to do is find the gradient of the function at t equals 1. So I'm going to go trace, and I'm going to scroll along until x equals 1. Can I just do it straight away? Enter an x value of 1, and it goes to that point. Now can you see there? What that does, it tells me the x value being 1, the y value 2.2, but it also tells me the value of the derivative at that point. So I know that the gradient of a tangent to the curve at that point would be 3.003. Okay, so you can get the graph to show it to you that way. Okay, so I can pick any point I like, pick an x value of 3.5, and I can see there that the gradient is negative. I can't read what it is actually, but if I actually had my calculator, I'd be able to. Okay, now there's another way you can do that, and that is if we go to the main menu again and go to the run matrix. Okay, what we're going to do here is we're going to go to maths, and we've got ddx. Okay, what we can do is we can put in that function. So we're going to put x squared, I have to put in x, it doesn't recognize t, cos x, so we're just doing the same as before, 2x sine x. And then what you're going to do is you're going to put that in for the x value you want. Hang on, got to get there. Why won't I do that? There we go. For the x value I want, so when x equals 1, and execute, and then I get the same answer that the graph gave me. Okay? You'll notice that in the graph, in the graphing section, it won't tell me what the value of the, hang on. Sorry, I need to go menu, no, sorry, give me 1 second. I need to go to shift, setup, the derivatives are on. What I need to do is just F1 for trace, go x value is 1. So it gives me dy dx, gives me the first derivative, but there's nothing there, unfortunately, to give me the second derivative. So you cannot find the second derivative using the graph. You have to go to the run matrix to answer question 3. And all we're going to do is, again, we're going to go maths, and you can see here we've got the second derivative. So F5, second derivative of my function, x squared cosine of x plus 2x sine x, and we wanted to know that, at the x value of 3. Okay, and there it is. So the value of the second derivative at the value t equals 3 is 0.430, 3 significant figures. Okay, so you can use your calculator to do complex ones or even simple ones. When you're doing paper 2, where you're allowed your calculator, you will unashamedly use your calculator to do it, because it will be inefficient to do it any other way. Okay, you know, I will teach you methods that allow you to differentiate a function like this. But if you've got a calculator to do it for you, it's just so much quicker to just use it. Okay, so bear that in mind. Okay, let me know if you need me to go through any of that with you.